This is a lesson on mensuration. In this lesson, we are interested in finding the arc length and sector area. We will want to know the relationship of a sector to the surface area of a cone. We want to find the volume and surface area of a cone or a pyramid. And finally, to find the volume and surface area of a sphere. We begin by looking at the arc length. The arc length is simply a fraction of the circumference of a circle. Circumference of a circle is 2 pi r, and an arc is a fraction formed by using the angle out of 360 times the circumference of a circle. Similarly, a sector, which is a fraction of the area of a circle, can be easily found by taking a fraction formed by using the angle out of 360 times the area of a circle, pi r squared. The fraction can also be formed in other ways. Instead of using the angle out of 360, we can also make use of the arc over the circumference. And finally, using the sector area over the area of a circle. Next, we will take a look at the area of a segment. But before that, we will want to know how to find the area of a triangle using the angle between two given sides. If we have a triangle that has two sides known and the angle in between, we can find the area of this triangle using the formula half AB sine theta. This formula is derived from the formula half base times height. Taking A as the base, the height is found by using height over B, which is equal to sine theta. This gives us H equals to B times sine theta. Thus, half base times height becomes half A B sine theta, where A is the base and B sine theta is the height of the triangle. Next, we want to find the area of a segment. A segment is a region bounded by an arc and a chord which joins 2 points on the circumference. The area of a segment is found by taking the sector area minus the area of the triangle. The sector area is found by taking the angle of 360 times pi r squared minus the area of the triangle, which is found by the above method, half the product of the two sides times the sine of the angle in between. This gives us 9.99 cm squared in this case. Let us now take a look at some more examples. In this example, we want to find the angle given the arc length and the radius. Since we are given the arc, we begin with the formula for the arc, which is angle of 360 times 2 pi r equals to the arc length. Next, we substitute in the values given to us. Radius is 5 and the arc length is 10. Simplifying this using the calculator, we get theta is 114.6 degrees. So remember to start with the formula, then substitute in known values. Similarly, in question 2, this time we are given the area of a sector and the angle. Again, we start with the formula. This time we use the formula for a sector. Angle of 360 times pi r squared equals to the sector area, which is 80. And simplifying this, we have the answer r equals 11.9 cm. In the next example, we have an example of a combined area. In this case here, we do not know a formula finding this area directly. Thus, what we can do is to divide it into figures that we know, and that is a sector and a rectangle. Thus, to find the total area, it is simply the area of a segment plus the area of a rectangle. Before we can find the area of a sector, we need to know the angle and the radius. In this case, the radius is L. To find the radius, I make use of trigonometry. 2 over L equals to sine 30, giving us L equals to 4. And using the properties of angles, I can find that the angle of the sector is 120 degrees. The segment is the sector area, subtract away the triangle. And in order to find the area of the rectangle, I need to find the length by first finding AE using Pythagoras theorem. Hence, we can now find the total area of the figure, which is the rectangle plus the segment. Area of a rectangle, 2 times the whole length, which is 24. In the next figure, we want to find the area of the two shaded moonlight structures. Again, we have to see the figure in terms of known figures. Here we see that the diagram can be divided into triangles, a triangle with two semicircles. We begin by finding the total area, that is the area of the triangle, plus the small semicircle and the medium semicircle. Next, we need to find the radius of the largest semicircle using Pythagoras theorem. Then taking half of that will give us the radius of the big semicircle. Thus, the shaded area of the two moonlight structures will be the whole area, subtract away the area of the large semicircle, half pi r squared. We now take a look at the relationship between a sector and the surface area of a cone. In this case, we can see that a sector can be made into a cone. And because the cone is made from the sector, they are related in three ways. First, the radius of the sector, which is L here, becomes the slant length of the cone. Secondly, the arc of the sector becomes the base circumference. So if the base circumference has radius r and giving us 2 pi r, then the arc is also equals to 2 pi r. Next, the curved surface area gives us the curved surface of the cone. Thus, the curved surface area is just the area of the sector. And this can be found by taking a fraction of pi L squared, L being the radius of the sector. And the fraction here is formed by using the arc over the circumference of the circle, which is 2 pi L. Simplifying this, we have the area pi RL. So if we want to find the curved surface area of a cone, we need the base radius and the slant length. There is another important formula to find the angle of the sector which made the cone. In order to do that, we need another formula. This is a formula which is formed by using the angle of 360 equals to the arc over the circumference. And cancelling away 2 pi will give us a formula relating the angle, the base radius, and the slant length. There is another formula which relates the sector area to the arc. We use the relationship of the fraction, which is the sector out of the full circle equals to the arc out of the full circumference. And simplifying this, the sector area can be found by taking the arc over 2 times the radius. We will now look at an example of 2 questions on sector and cone. In question 1, we have a sector given the arc length, which is made into a cone of height 6 cm. Now we know that in order to find the radius of the sector, which is L, we need the base radius. The base radius can be found from the base circumference, and the base circumference equals the arc length of the sector. Thus, we use 2 pi r equals to the arc length of the sector to find the radius of the base. And using Pythagoras theorem, we can find the radius of the sector L. In the second question, we are given the height of a cone that is made from a sector with angle theta. The base area is given as 24 cm squared. From the base area, we can find the radius of the base. And once again, using Pythagoras theorem, we can find the slant length. To find the angle, we must use the formula theta over 360 equals to R over L. R is found from the base circumference, and L is found using Pythagoras theorem. And using the formula, we can find that the angle is 174.2 degrees. We now take a look at the volume of a cone and a pyramid. A right pyramid has a vertex that is directly above the center of the base. And such a pyramid has a volume of 1/3 the base area times the height. A cone is a special pyramid, thus it has the same formula. And since the base of a cone is a circular part, we have 1/3 base area pi r square times the height. Next, we want to find the surface area of a pyramid. A square pyramid has 4 triangular surfaces, and the height of each triangular surface can be found by Pythagoras theorem. By forming a right angle triangle with the height of the pyramid, we can find the height of the triangular surface, which is x squared equals to 3 squared plus 4 squared in this case, giving us x equals to 5. Once we have found the height of the triangular surface, we can take half base times height and multiply by 4 plus the base area. In this example, the base of the pyramid is a rectangle. And if the base is a rectangle, then there will be 2 triangles with the same height, and the front and back triangle have a different height from the first triangle. Therefore, we begin by finding the heights of the triangular surfaces using Pythagoras theorem. We have the height x squared equals to 3 squared plus 4 squared. The length here is obtained by taking half the length of the side of the rectangle. And the other triangle, the base of the other triangle is found by taking half the side of the rectangle, which is 2. And the total surface area is found by taking the base area plus 2 of the blue triangles and 2 of the front and back triangles, giving us 70.832. Next, we take a look at the volume of a sphere. The volume of a sphere can be found by using an experiment or deriving from algebraic source. Is 4/3 pi r cubed, and the surface area of a sphere is found by 4 pi r squared, which is simply 4 times the area of a circle radius r. We also need to take a look at the volume of a prism, which is simply base area times the height. And if it is a cylinder, then the base area is pi r squared times the height of the cylinder. The surface area of a prism is simply 2 base area plus the perimeter of the base area times the height. And for a cylinder, 2 base area is 2 pi r squared, and the curved surface area is found by taking the base perimeter, which is 2 pi r, times the height, In this topic, we are interested in finding the volume and surface area of combined solids. The volume of this solid here is simply the volume of a cone added to the volume of a cylinder. Volume of a cone is found by the formula 1/3 pi r square times the height, and the volume of a cylinder is pi r square times the height, giving us a total of 58.6 cm cube. Next, we need to find the total surface area. Before that, we need to find the slant length in order to find the curved surface of a cone. The slant length is found by using Pythagoras theorem. And the total surface area is simply the curved surface of a cone, which is pi rl, and the curved surface of a cylinder, which is 2 pi rh, and the base is pi r squared. Substituting in the values, we have a total of 84.1 cm squared. The next type of sums is a transfer of volumes. In question 1, we see that a solid cylinder is melted to make into a cone of base 2 cm. Since one solid is made from the other, their volumes are equal. The volume of a cone equal the volume of a cylinder. We put in the formula for each. In this way, pi is cancelled out and we can find the height, which is 7.29 cm. In the second type of transfer of volumes, we see 3 spheres being completely submerged and which cause a rise in the water of height h. Since the spheres cause the water to be risen, their volumes are equal. Thus, we form an equation of the volume of water raised equal the volume of the 3 spheres. And finding the volume of water, which is 10 times 6 times the height, equal to 3 times volume of a sphere, 4/3 pi r cubed. And simplifying, we have the height equals to 1.68 cm. This ends the lesson on mensuration. Thank you.